All right. Hello, good afternoon, and good morning, wherever part of the globe you are watching. This is your host, Mike Espina, and welcome to Math Agility Live. This is our platform where students can send in their math homework problems to our social media channels, and we will answer them via Facebook Live every Tuesday and Thursday. That is PST, and that's Wednesday and Friday, Manila time. So before we start answering the problems for Elimination Round 3, I would like to congratulate the following people, our semifinalists. So number 1 is Kyle Beton de Doro. Number 2 is Justin Magdato. Number 3 is Feby Flormata. And then fourth is Bryle, Ivan Layug, and then Daniel Atanasio, James Carl Julian, and John Paul Pereira. So that's it. So, and those who did not make it to round 3, you can still register for the elimination round 4. So just visit our page for more instructions and information, or if you want to read the whole mechanics of the game. So tonight, as I mentioned, we will be discussing the solution to the problems in the MAC 2021 elimination round 3. So let me share my screen to you. Okay. I hope everyone can see my screen. Okay, let's just me tests annotation. If I can annotate here. Okay, so let's read question number 1. So find an equation of the hyperplane H in R to the fifth that passes A, -3, comma, -4, comma 1, comma 3, and comma -5, and is normal to U, bracket 2, 3, 5, -1, and -2. So the coefficient of unknown equation H are, of course, components of the normal vector U. Thus, the equation of H is in the form, so whatever is in elements of U would be 2x1 plus 3x2, 5x3 minus x4, and negative 2x5. That would be equivalent to k. And then since it passes through point A, what we need to do is just substitute the values in the equation in k. So negative 3 would be x1, negative 4 would be x2, negative uh, 1 would be x3, and then 3 would be x4, and then negative 5 would be x5. So you will form this equation here, right? And to be able to get k, of course, so just solve this, add and subtract all of the data, all of the numbers to the left, and you would get k equals -6. So again, the equation of the hyperplane will just be our initial, this one, the initial equation, but then we have to input -6 at the end. So that's question number 1, easy round 1. Okay, let's move to easy round, question number 2. Okay, let's read the problem. Hold on. So Captain Reed, the captain of the Agility Shipping Company, is sailing the ship due east when a light is observed bearing north 59 degrees 36 minutes 25 seconds east. After the ship has traveled 5,300 meters, the light bears north 39 degrees 25 minutes 43 seconds east. If the course is continued, how close will the agility ship approach the light? So answer should be in two decimal places. So the first thing that is required to get a half point is, of course, we need to draw the diagram. So we have the ship at point A here, and the bearing given is 59 north 59. So this one for north 59, degrees, 36 minutes, 25 seconds east, right? And the other bearing that is given is after the ship traveled 5,300 meters, so it traveled 5,300 meters, at point B, the bearing would be 39 degrees, 25 minutes, 43 seconds east. So we can see, let me change the color of my pen to red, that we form a triangle here, right? So we know that this is 5, 3. So the bearing is 59. So just subtract this on 90 degrees and we would get the angle inside the triangle, which is 30 degrees, 23 minutes, 35 seconds here, right? And on the other hand, since this is, we know that it's 39 degrees, which is the bearing from the north, we just need to add 90 degrees in this case, right? To be able to get the angle inside the triangle, which is 129 degrees, 25 minutes, 43 seconds. Okay, so let me erase this. Let's clear it. So let's go to the solution. So it's an oblique triangle ABL. So this is A, B, and this is L, where the light source is located. So AB as given is 5,300 meters, right? Let me just move this a little bit. Okay. So this is 5,300 meters for AB, and then angle BAL as we have solved is 30 degrees, and angle BAL is 30 degrees, angle ABL is 129 degrees, 25 minutes, 43 seconds. So we will be able to solve angle ALB, right, which is the angle here, right? ALB. ALB here, right? So this is 20 degrees, 20 minutes. So this angle here would be 20 degrees, 10 minutes, 42 seconds, right? And so BL, so the length from B to L, we can compute by um, the sine law. So BL over AB. So BL over AB sine BAL over sine ALB, right? Angle ALB. So we can solve BL, so which is BL. So AB, we know that it's 5,300 meters. So this is the here. And then we already know that BAL is 30 degrees, 23 minutes from here. And then what is sine ALB? So that's the 20 degrees we already solved, which is here at the denominator. So we'll be able to solve BL, which is 7,723.52 meters. Okay. So in the right triangle BLC, so where is BLC? So the other triangle on the right hand side. So let's clear this again. So BLC is this triangle here. And this is a right triangle. So this means this is 90 degrees. So BL, we already solved it at 7,773.52, right? This one here. So to be able to compute CBL, angle CBL, this angle here. So just subtract the 39 degrees, right? So which is this 90 minus 39 degrees. So we get 50 degrees, 34 minutes and 17 seconds. So this is that angle here, CBL. And now we need to compute CL. So CL would just be the sine of angle CBL, right? So, so katoa. you still remember this acronym. So if it's sine, right, it means it's opposite over hypotenuse. So if this is my angle, so this is my angle, right? So opposite, this is my opposite, right, which is LC or CL. So CL, right, over up hypotenuse, which is BL, right? So sine theta, or if this is your theta, which is, we already know that it's 50 degrees, 34 minutes and 17 seconds. So we can solve CL, right? So CL is basically BL times sine of, what's that? 50 degrees, 34 minutes and 17 seconds. And our answer should be 6,004.40 meters. I think, okay, so that's it. So we solved already question number 2. Let me clear this. Okay, so let's go to question number 3. And if you have any questions, you can write down at the comment section on our Facebook page, on our Instagram account and Twitter account. Okay, so next question is, given the function, the rational function f of x equals x squared minus 1 over x squared minus 4. So let's do number 1 requirement is to find the whole. So actually, holes can be solved if after factoring the, you call this, the rational function, and we did get any common factor or any common uh, any common factor that those that were canceled will be the whole. So if you can see, we already factored out x squared minus 1, which is x plus 1 and x minus 1 right here, which is in the numerator, and we factored out also the denominator, which is x squared minus 4. So that's the factor is x plus 2 and x minus 2. So we cannot cancel anything from here. So our answer for number 1 is none, right? No whole. Okay, for the vertical asymptote, for number 2, that's actually um, the one in denominator when we equate it to 0. Or that's the value that would make the rational function uh, undefined or becomes infinity. So if we let x plus 2 equal to 0, so this would be x minus 2. So that's one of the vertical asymptote. And the other one is x minus 2 equals 0. So this is x equals 2. So we have two vertical asymptotes, which we already listed here in item number 2. So x equals negative 2 and x equals 2. So for the next is uh, horizontal asymptote. So horizontal asymptote can be taken when from the highest degree of the numerator and the denominator. So we have x squared and x squared, since both the numerical coefficients are 1, so this should be 1, right? So this is your horizontal asymptote here. Okay, and then for y-intercept. So y-intercept is when we make x equals 0, let equal to 0, right? So from our rational function, y equals x squared minus 1 and x squared minus 4. So just substitute x to 0. So 0 minus 1 and 0 minus 4. Okay, so hold on. Let me just adjust this. So we get, what's the answer? So that is 1/4. So meaning our coordinate for the y-intercept would be 0 and 1/4 here. And then for the x-intercept, so it's the other way around. Let's make y equals 0 and then solve for x, right? So when we substitute y equals 0 in this equation, or in the rational function, we will get x squared equals 1 So therefore x is equal to plus or minus 1. So meaning our x-intercept would have negative 1, 0, and positive 1, 0 here, right? Okay, so let's clear this. And then let's go for number 6, so the domain. So if you use any software or graphing calculator, let's try to graph it. So we save more time in graphing it. It's not required not to use a calculator in this round. So let's move it. So I'll show you this. So this is the graph using Desmos. And if we look at the domain, so domain means all the x values, right? Where it is defined in the x. So meaning the x going here towards negative infinity, and on the right side it would be infinity or positive infinity. So if you look at the red curve, so that's these are the graph of the rational function we're solving. So this blue line here is our first vertical asymptote, which is x. This is x equals negative 2. And if you see the green line, which is x, is the other vertical asymptote we initially solved earlier. So meaning from negative infinity to negative 2. So if it's an asymptote, uh, the curve will not touch that portion, right? So we also have a horizontal asymptote y equals 1 here, right? So this is y equals 1. If you can see that violet line horizontally here, so that's your y equals 1. So meaning from negative infinity to negative 2. So that is parenthesis because it doesn't touch on that point. So that's the first value. And then the second part of the graph would be from negative 2. Again, it's a parenthesis. 2 to positive 2. Here, another parenthesis because both x negative 2 and x equals 2 are vertical asymptotes. And then the last part of the curve would be from 2. Again, it's a parenthesis because it will not touch the vertical asymptote towards negative 2 and then moves to positive infinity. So 2 parenthesis 2 comma negative positive infinity. So the domain would be this. Okay, so let's clear them. How about the range? So when we're talking about the range, we're talking about the y values of the graph. Okay, so if we look at the y values, let's start from so this time we're looking at the y-axis. So anything that goes up would be positive infinity right here, and below would be negative infinity. So let's start from negative infinity because the curve would continue. So if I'm gonna put an arrow, this will continue infinitely. So it goes to negative infinity. So the start would be negative infinity. And since it crosses uh, 1/4, right, of y here, so 0.25 is 1/4 in fraction. So this part here, so that's this point here. So we start from negative infinity, but this time since it crosses y at 1/4, so we use the bracket line, right? So negative infinity comma 1/4 bracket, and then the curve still continues. So we know that this line here is our horizontal asymptote. That's y equals 1, right? So it would not touch, the curve would not touch this line, this horizontal line, which is a horizontal asymptote. So again, we will use a parenthesis instead of a bracket. So that's 1 and moves toward the positive infinity. So that's the other part of the interval of the range. So 1 comma infinity. Okay. So since we already graphed it, so this is how it would look like, a rational function, and The next question is to solve the slope. So to be able to solve the slope of this function, let's just take the derivative, right? So derivative of this would be the quotient rule, right? So this would be the answer. And what else? So the question is slope when x equals 2. So there's a value given. So let's substitute the value x equals 2 from the derivative of the function. So f prime of 2, when we substitute here, is negative 6 over 2 in the numerator here. And then 2 squared minus 4 would be 0. So this would be negative 12 over 0. So anything, so this would be infinity, right? Or undefined. Okay, so that's the answer for number 9. And then for number 10, so the area is to compute the intersection of the curve and y equals negative 4. So by substituting the value of negative 4 to our equation, to a rational function, I mean, we will get the value of x is equal to plus or minus square root of 17 over 5. So to solve the area, we will get the integral of this function 4 plus negative x plus x squared over negative 4 plus x squared dx. And our limit is the one that we solved from negative square root of 17 over 5 up to square root of 17 over 5 positive. So, and we will get here 2 square root 85 minus 3 hyperbolic tangent inverse of square root of 17 over 5 over 2, which will give us 13.6334. So you can also use the integral, which is the area 5x plus 3/4 log 2 minus x minus 3/4 log x plus 2. And then evaluating it at square root plus or minus square root of 17 over 5, you will also get 13.634. Okay, so that's question number 3. Is this? So now let's go to question number 4, easy round. So the question is, use the table of values of f of x and y to estimate the value of f of x 3 comma 2, f of x 3 comma 2.2, f of x 3 comma 1.8, and f of x of y 3 comma 2. So for number 1, so we're solving f of x 3 of 2. So let's locate where is uh, 3 from the values of x. So this one here. Oh, let me change the color. So here, and 2 is here, right? So from the numerator part, which is the y values. So what are the y values? So this would be in between 23 and 10.2, in between 3, right? So this is the part here. And the denominator would just be your x values, which is 3.5 and 2.5, right? So we got 3.2 for the first answer. And then let's solve now 3 and 2.2. So 3 and 2.2 would be this x value here and 1 here. So the value in between the x value of 3 would be at the column 2.2 would be 25.1, which is this, and 9.5, which is this. And same thing in number 1, the x values in between the intersection of x3 and y2.2 would be 3.5 and 2.5 here. So once you solve it, you will get 15.6. Next is f of x 3 comma 1.8. So clear this again. So we're taking 3 in the x values, and this time it's 1.8. So the values in between this in the y column would be 20 and 15.5. So this is 20, 15.5. Same thing with question 1 and 2. The denominator will just be the values from the lower and upper part of 3, which is 3.5 and 2.5. And this time we'll get the value 4.5 as our answer. Okay, now let's solve f of x of y and 3 comma 2. So this time it's 3 comma 2 at x and y. So 3 is here and 2 is here. So we initially solved that part at 3 and 2.2. So 3 and 2.2, 3 and 2. So it's in between this value and this. So for the y part, that's 15.6 and 4.5 here. We already solved that initially, but this time the denominator would be the y values of 2.2 and 1.8 here. So if you solve that, you will get the value 27.75. All right, so let's go to question number 5. Okay, so let me read the problem. So this is, I think, a credit card problem. So an unpaid bill of $2,000 had a due date of July 1 on Lee Min Ho's credit card. A payment of $600 was made on July 7. Then a purchase of $150 was made on July 15. And subscription of $2,000, $200 was also charged on July 21. Additional purchase of $500 was also made on July 26. So if the APR is 18%, find the average daily balance and the finance charge on August 1 bill. So the best thing to do for this credit card uh, problem is to make a table. So let's check it one by one. So from July 1 to 6, here we have a balance of $2,000, right? So we haven't purchased any or paid anything. And those are actually 6 days. So let's, to be able to get the unpaid balance times the number of days, we just multiply 2,000, right, times 6. So we'll get 12,000 here in this column. So from July 7 to July 14, so actually he made a purchase, he made a payment of $600. So there's a negative 600 here. So to be able to get the balance each day, so 2,000 minus 600, so this is 1/4. And from July 7 to 14, that's 8 days. So multiply again 1/4 times 8. So you will get $11,200 on the second row in the last column. Okay, from July 15 to 20, Lee Min Ho purchased $150, right? So this is that one. So if you purchase again, you add it to the balance, right? So the last balance was 1,400. So plus 150, so that's 1,550 here. And from July 15 to 20, that is actually 6 days. So to be able to get the last column, so 1,550 times 6 is 9,300 here. Okay, so let's move to, and then the problem says Lee Min Ho got a subscription of $200. So it's another um, increase on the balance. So from July 21 to 25, so that's $200. So we need to add that to the last balance, which is 1,550 plus $200. So we get $1,750. And from July 21 to 25, that's 5 days here. So we will multiply again 1,750 times 5, that's 8,750. Okay, so from July 26 to 31, he again purchases an amount of $500. So we need to add that to 1,750. So we get $2,250. And from July 26 to 31, that's 6 days. So multiply 6 times 2,250, that's 13,500. So the next thing we need to do is add all these numbers in the unpaid balance column, which is the last column, and we will get 54,750, and the total of days would be 31 here. Okay, so let's clear this. So now the first question is, of course, the average daily balance. So this is basically the sum, which is the 54,750 divided by the total number of days, which is 31. So, and we get average daily balance of 1,766.13. Okay, and then for question B, or the second question, what is the finance charge? So the formula for finance charge would be the average daily balance, so which is this, right? Times the APR. APR given is 18%. So this is 18% times the number of days in billing cycle, which is 31, right? 31 days divided by 365 days here. So solving that, we're going to get a finance charge of $27. So if you solve both of this, you will get 1 point. Okay. All right. So before we continue, where am I? So let's pause for a short break before we proceed with the average problems 6 to 10, or average A1 to A5. Okay. So stop sharing.
Kids dread math, but unfortunately, parents are busy juggling responsibilities and are unable to help their kids with their math homework. High school and college students find math to be difficult and need help with their math and advanced math subjects, while working college students don't even have enough time to study for their math homework. It all boils down to the fact that to ensure continuous success for students in their mathematical study, getting the right help is most important. Unfortunately, current solutions only deliver hours of math preps without spaces for students to even ask their troubling questions. We understand the flaws of these methods, and we've crafted a new solution that works for all students, even low-class junior students. Introducing the Math Agility Math Express 10, Math Express 20, Agile Max 15, and Agile Max 30. The simple but effective solutions to help students through their math difficulties and homework. At Math Agility, we are focused on providing quality tutorials and test preparations to increase the confidence of students with math concepts and problem solving. And with each subscription package, every student gets to enjoy access to math support like never before. The Math Express 10 allows students to ask 10 questions valid for 7 days. The Math Express 20 allows students to ask 20 questions valid for 30 days. The Agile Max 15 allows students to ask 15 math questions weekly, while the Agile Max 30 allows students to ask 30 math questions monthly. Now, busy parents can worry less knowing their kids have the best math help while in high school. College students and working college students can get the help they need with their homework. Getting started is easy. Simply create an account, log in, choose a subscription package, pay, and that's it. Start asking your math questions and get the help you need. Visit www.math-agility.com.
Okay, welcome back. So let's go back to the average question. Number one. So annotate. Okay, so uh, question A1 is each problem in the average round. So we have five problems here, and each would be 2 points. So the question for A1 is use the given confidence level and sample data to find the confidence interval for the population standard deviation sigma in each dollar in nearest dollar. So assume that a simple random sample has been selected from a population that has a normal distribution. So these are the given information. We have a salaries of data scientists who took econometrics course in college. We have 90% confidence interval, and our n, or the sample number of samples, is 41, and x bar, which is the sample mean, is $100,000, and s, which is the sample standard deviation, is $25,275. So required is to solve for the lower limit of population standard deviation, that's 1 point, of sigma. So population standard deviation is sigma, and then the upper limit of population standard deviation of sigma, which is also another point. Okay, so let's start solving. So this would be the solution. So since we're getting the boundaries of standard deviation, lower and upper limit, so we're actually using the chi distribution here. So first we need to solve the degrees of freedom. So we have 41 minus 1, it's 40 degrees, right? So chi-squared left and chi-squared right, which is the test statistics shown in the graph here. So we see that it's not a normal distribution. So we have given also a 90% confidence interval. So that's the middle of the curve. Of course, on the other end would be 5% each. So 5% here and 5% here. So to be able to solve this, I'm actually using Excel. So we know that it's a cumulative, right? So XL would be 5%. So we need to use the command or the function chi.inv. So that means chi-squared distribution inverse. So this is the command in Excel. And input 5% and the degrees of freedom, which is 40. So you will get 26.5093. So for the right side, chi-squared r. So again, it's chi inverse. So, but this time you need to add for the probability or the percentage from here up to here. So that's 90% plus 5%. So that's 95%. And then we'll use again similar degrees of freedom, and we will get this value of 55.7585 as our chi-squared r, sub r. Okay, so let's now compute the confidence interval for the population standard deviation sigma. So we will use this formula. So sigma would range from n minus 1 s squared over chi squared sub r, and of course the square root of that. And on the upper limit would be the square root of n minus 1 s squared divided by chi squared sub l. right? So simply substitute what we already solved. So 41 minus 1 times 25 minus 25,275 squared divided by 55.7585, right? And then we will be able to solve 21,470.48. And then on the upper limit, so that's square root of 41 minus 1, and then times 25,275 squared divided by 26.5093, we will be able to get 31,047.17. And since the required is in the nearest dollar, so the lower limit would be 21,407 and the upper limit would be 31,047. Okay, so this would be our confidence interval. Okay, so if you have any questions, write down in the comment section below of our Facebook page and Instagram account and Twitter account. Okay, so let's move to question number 2 of the average problems. Okay, so let's move question number 2. So this is another statistics problem. Just give me a second. So you are conducting a study to see if the proportion of men over 65 who regularly have their prostate examined is significantly different from 0.24. So you use a significance level of alpha equals 0.02 and you obtain a sample size n equals 345 in which there are 90 successes. So the first requirement is to state the null and alternative hypothesis. So it's always that our null hypothesis would use the equality sign. So and the claim here is that we the prostate examine is significantly different from 0.24. So it means it's not equal to 0.24. That's the claim, right? So that's our alternative hypothesis here. So that's alternative. And our null is, of course, the one that uses the equality sign, right? So this is alternative is always the claim. Okay. So let's do question number 2. Find the population standard deviation in 4 decimal places. So we will, since this is a proportion problem, sample proportion, we would use the population standard deviation formula. Sigma equals square root of p, 1 minus p all over n. So p is actually the population proportion, which is the one we're using in formulating our hypothesis, which is 0.24 here, right? So 0.24 minus 1 minus 0.24 all over 345, and then get the square root of that. We will get the sigma equal to 0.0230. Okay, so if you get that, you'll get 0.4 points. So let's move to number 3 requirement for this problem. So find the test statistic for this sample in 4 decimal places. So to be able to solve for the test statistic, so we need to get first the sample proportion. So that's different from the population proportion, which is P equals 0.24. So it is mentioned in the problem that we have 90 successes out of 345 from a sample. So that's our sample proportion here. So 90 over 345, you'll get 0.261. So, and then let's use the formula for the test statistics Z distribution, or Z. So that's P prime, or sometimes they use P bar minus P. So I'm using prime here in this particular formula, divided by the square root of P, 1 minus P all over N. So that's equal to 0.261, which the one we already solved here, minus 0.24, which is the population proportion. divided by 0.0230, which is our population standard deviation here, right? So, and we will get 0.9130 as our test statistic. Okay, so now we already solved that. So the fourth requirement is to find the p-value for this sample in 5 decimal places. So again, I'm gonna use Excel to solve our p-value, and since this is a two-tailed test, right? So in a two-tailed test, so we have here our rejection region, right, on both sides. So to test for the p-value, so we need to multiply 1 minus the normal distribution of p prime, p, sigma, and cumulative. So meaning cumulative will start from 0 here up to here, right? That's why we subtract 1, so to be able to solve this area here. And we will multiply it by 2. Or we can also solve this part here since it's cumulative and then multiply by 2. They will get the same thing. So the p-value is 2 times the quantity of 1 minus norm dist. So this is the command from Excel. Um, so just input your p prime, which is 2.61 here, and your p, which is 0.24, and then what else? So 0.0230 is your sigma again, and you will input through, meaning you're taking the cumulative value, right? So from here up to here, and multiplied by 2 because we have two-tailed test here, right, on both ends of the curve. So our value for p is, or our p value is 0.36122 here. Okay, so the next requirement is the state your conclusion by explaining first the decision of rejecting the null, accepting the null, or fail to reject the null. So since our p-value is greater than our alpha, so our alpha is our confidence level, right, of 0. Not confidence levels, rather significance level. So our p-value is higher than our alpha of 0.02. So when p-value is higher than alpha, so we fail to reject the null hypothesis, right? So what is our conclusion then? So therefore, there is not a sufficient sample evidence to support the claim that the proportion of men over 65 who regularly have their prostate examined is different from 0.14, meaning they are actually equal for both for our samples, right? So it's not different from 0.24. That's what I mean. Okay, so let's move to question number 3. So this is a linear algebra and combination of trigonometry, not differential equation, calculus, and physics. Okay, so question number 3 is a new Pokemon ball named as Agility Ball is being tested and thrown in the air at time t equals 0. It describes a parabolic trajectory s of t in the xy space where the x-axis is the ground and the y-axis is the distance from the ground. So this is s of t, comma, parenthesis t, wt minus gt squared over 2. So question number 1 is to compute the velocity vector vt and the acceleration a of t of the ball. So that's question 1. So let's go. Okay, let's read first all the requirements, and then second requirement is to compute the unit tangent vector u of t to the trajectory. The third requirement is compute the tangential acceleration of the ball and find when it is 0. And then, excuse me. And fourth is the agility ball spins in the air as designed, so that the trajectory of the air bulb is s sub bulb of t is equal to s of t plus the quantity s cosine omega t, s sine omega t. Find the norm of a sub bulb of t of the acceleration of the air bulb. Okay, so for question number 1, so if you answer 1 to 4, that's 5 points each. So let's start with the velocity vector vt and the acceleration at. So at is bt is simply the derivative of st, which is s prime of t here, right? So if you get the derivative of s of t, so t becomes 1. So here, and the derivative of the second one is w minus gt, right? So, and then for acceleration, that's the derivative of the velocity or the second derivative of s, or the displacement, right? So, taking the derivative of 1 is 0 here, and the derivative of this would be just negative g. That is respect to t, right? So, w would be a constant, so it's 0, and t would be equal to 1. So, that's negative g here, right? So the second requirement is the unit tangent vector of u of t. So this is the formula for getting the unit tangent vector. So u hat equals v hat is equal to v over, we call this the the magnitude of v here. So 1 over, so our v is actually 1 over wgt, so which is this, right? And the magnitude of b is simply the square of uh 1 plus this. So our element x and y, it's simply square root of x squared plus y squared. So if this is your x and your y, so this would be 1 squared plus w minus gt squared, square root, right? So that's what we get here. So just simplifying, so we have the answer for u hat here, which is the unit tangent vector ut. Okay, now let's solve for question number 3. So the tangential acceleration of the ball and when it is 0. So to be able to get a of sub u, so that's vector a times, or the dot product of vector u. So we already know that our acceleration is 0, negative g here. So that's what input here. And our u is this value here. So we multiply it here. So simply distribute uh, 0 and negative g for 1 and double, and for the second part here. So that's 0 plus negative g, w negative g over square root of 1 plus w gt squared here. So let's try to simplify that. So negative g quantity w minus gt over square root of 1 plus w minus gt squared. So let's take out the negative, and we will get this answer here, which is g quantity gt minus w all over 1 plus w minus gt squared. Okay, so let's move to the next requirement, which is requirement number 4. Not yet. So what would be the value of uh, what's the question again? So we're solving for time. Yeah. When it is 0, so what is the what, compute the tangential acceleration of the ball and find when it is with is 0. So when it is 0, so we just substitute 0 from from here. So this is the 0 we imputed, or we substituted. So uh, simplifying it, we will get g quantity gt minus w equals 0. So we'll be able to get t is equal to w over g. So this is when a sub u is equal to 0 here. Okay, and then for question number 4, we need to solve the norm or the magnitude of a bulb of t. So this is given in the problem, right? So S of bulb t is st plus S of cosine omega t and S sine of omega t. So if you take um, a valve of t, that's actually the second derivative of S valve of t, right? So we will take the second derivative of this whole thing here, right? So a valve of t is a of t, and then the second derivative of the second term, which is this, and we already know a of t. We already saw this earlier, which is 0 and negative g. And then the second derivative of this uh, vector here is negative s omega squared cosine omega t and negative s omega squared sine omega t. So just adding these two together, this matrix here is negative s omega squared cosine omega t and negative g minus s omega squared sine omega t. So we already solved the vector, and we need to find the magnitude, which is the magnitude of a valve of t. So simply get, so again, this is your x and this is your y. So to get the magnitude of a valve of t, just get the square root of x squared plus y squared. So since this is your x here, so we get the square of that, and this and y is the second expression here, which is this. So if you expand it, you'll get the second line here. And if you rearrange them, you would observe that we can combine s squared omega squared and with cosine squared omega t and sine squared omega t here. We just factored it out afterwards, right? And since in trigonometry, cosine squared theta plus sine squared of theta is equal to 1. So this would be equal to 1 here. So if you look at our final answer, what is left is s squared omega 4, because this whole thing here is a trigonometric identity equal to 1. So this is what is left, and then copy the rest of the expression, which is g squared plus 2g s omega squared sine omega t, and then of course the square root. Don't forget the square root. So this would be the answer for our requirement number 4. Okay. Okay, let's move to question number 4 of the average problem. So again, this is a linear algebra, physics, and trigonometric trigonometry problem. So let's read the problem. Suppose Kim So Hyun and Jun Ji Hyun are towing a box by ropes attached to the box as shown in the figure below. Determine the magnitude of the resultant force on the box by using trigonometry and vector algebra. How vector algebra is also sometimes used by linear algebra. How would the problem be modified if a third person pulls onto yet another rope? So first is we need to solve using the trigonometric solution. So let's draw the force diagram. So 175N is here, and we know that the angle between the two forces is 37 degrees. So this is the second force, F2 275 here. So if we draw 175 reflecting here on the end by connecting all the arrows and heads of our forces, and we connect the F1 to F2 here, uh, we will form, of course, if we extend the line, if you see the green line here, it is still 37 degrees, right? So the resultant would be from the end of F2 to the arrow of F1. So this is the resultant here. The pink thick arrow here. So what we will get is a triangle. So if we know this is 37, so it's a supplement. But the supplement of 37 is 143 degrees here, right? And F1 is 175 and F2 is 275. So, but the trigonometric solution for this is using the cosine law, right? So cosine law is basically r squared equals f1 squared plus f2 squared minus 2 f1 f2 cosine of theta. So the side we are solving opposite the angle that we know, which is 143 degrees, is our theta, right? So simply substitute that in the equation and we will be able to solve the resultant force of 47.92 Newton. Okay, so that's the trigonometric solution. Now let's do it by vector algebra solution. So rotating the so what I did here is I rotated the axis of the forces such that F1 will be parallel to the y-axis. So I rotated it counterclockwise and then this will be the resulting force diagram here, right? So I resolve the component of F2. So if you see the green line, so F2 sine 53 and F2 cosine 53 here. So I got the angle here because that's the complement of 37 degrees, right? And of course, F1 is in the y-axis here. Okay, so let's move to the next part. So F1 is 0 and F1. So this your X is 0 here because it's coinciding the y-axis and F1 is your Y. While in force 2, so I actually took the components of F2. So your X would be F2 cosine theta and your Y is F2 sine theta. And then, of course, the resultant would be adding these two vectors or these two matrix. So 0 and F would result to F cosine theta and F1 plus F2 sine theta would be F1 plus F2 sine theta here. So to be able to get the magnitude of R, so R with the double line on each side, again, it's x squared plus y squared square root. So F2 cosine theta is this part here. And then the y is just squaring this part here. So, and we know that the theta is 53 degrees. So we also substituted here and the values of the forces, which is 175 for F1 and 275 for F2 here. And then once we get the square root, we get 427.92 Newton. So that's the answer for that. And then let's move to question letter C. So the question is that if another person pulled the box together with those two people we mentioned, so the resultant force using trigonometry would involve a quadrilateral instead of a triangle. So because there's another force added, so it's not a triangle anymore, but a quadrilateral. There would also be two steps in getting the resultant force in this case, right? First, that we combine the first two forces and then get the resultant, and then add the third force to the resultant to be able to get the final resultant force. So that's how trigonometric solution would be. And then, however, in using vector algebra, it will be easier as the resultant force R is simply the sum of the three forces, right? So R would be F1, F2, F3. F3 would be the force of the third person, and the magnitude would still be the same, taking the squares of each of the components, R, right? All right, so that's question number 3. So let's move to question, no, that was number 4. So let's move to question number 5 on the average problems. So let me read the question. So the robot Mac AG has an extensible robotic arm which is set to rotate around the origin with a time-dependent angle omega t. The robotic arm can change its length m of t using a piston system. Oz, the programmer of Mac AG, has the goal to program the piston system such that the free extremity is constrained to follow the line y equals mx plus b. So this is the diagram given. Find the expression of m of t and solve when the y-intercept is 10 and the angle is 45 degrees at time equals 1 second. So basically, we're solving for the expression of m of t, right? And this is your line here. So this blue thin line here. So the points is to solve m of t, that would be 2 points. So the first thing we need to do is to take the position vector of the free extremity of the robotic arm Mac AG given by S of t, right? It's the displacement or the position. So that is from O to D. So that's the full extent or full extremity of the robotic arm at the boundary of the line, the blue line, which is y equals mx plus b. So that's OD from here up to here, right? Oh, sorry. Up to here. So, and that would be empty. So, if you're gonna solve it into components, so let me change my color. This would be your cosine omega t, right? Because the angle here is omega t, and this would be sine omega t. So that is mt times cosine omega t. So mt, sorry. mt, mt here because this force is mt. The resultant force is mt. So mt quantity cosine omega t and sine omega t here, right? So let's move to the next part on solving this. So in order for this position to be a point on the line y equals mx plus b, so we will be following the expression. So this must be true. So basically, this is your x, right? And this is your y. So let's substitute it in the line equation of a line. So your x is mt cosine omega t times the slope m here, and your y is mt sine omega t, which is on the left hand side of the equation, plus the y-intercept b, right? So let's solve for mt. So we will get mt equals b over sine omega t minus m cosine omega of t. So there's a given initial condition. So when y-intercept is b equals 10, omega is 45 degrees, and time is 1 second. So at m at 1 second, so simply substitute that. So we'll get the value 10 over square root of 2 over 2 minus m square root of 2 over 2. So this would be the final answer. So m is still here because we don't have any value given for m. All right. Okay, so that is actually question number 5 for the average round. So again, let's pause for a break before we proceed with the difficult uh, problems. Okay, so
If you are weak in math or have less time studying because of work, then Agile Max and Math Express will be immensely helpful for you. Using Agile Max and Math Express is something easier, and you have to follow these steps. For creating an account, log into www.math-agility.com. Click the icon on the top right corner. There will be an option available for creating account. After clicking the Create Account, this page will appear. You have to fill all the details, like first name, etc. Check the box, I am not a robot, and then click Submit. You will receive an email about account confirmation. For existing customers, first click the icon to log in, input your details. You will see an option of subscription and click Subscription to choose the package that will fit your needs. The subscription package will show different variants of Math Express and Agile Max. Click Buy Now of the product you want to purchase, and then click View Cart, and then click the Checkout. After this, input your billing address and click Continue to Payment. Choose Payment Method and then click Pay Now. Click Math Agility to go back to your account page, or click Continue Shopping to buy more. For updating the Student Dashboard profile, click the Student Dashboard and fill up your information. Asking math questions by students. To ask math questions, click the Ask Questions and choose your subject. You can type your question and can attach a file. You can view your posted questions in the question list and the remaining unused questions. When you click View from the question list, this page will appear. The math experts from Math Agility can see the questions and can reply with a solution. When students click View, they will see this page. If the student is satisfied with the solution, then they can click on the Close Questions.
All right, I'm back. So let's go again to our list of problems. So we're now answering the difficult problems. Let me just annotate. Okay, so let's go to question D1, right? So again, there are 5 problems for the difficult question, but this time you will get 4 points each if you solve the problem. So the first question for the difficult would be this. So D1, sense and observe that curve A is the set of points x comma y such that x equals s plus 1 comma y equals negative 2s plus 3, where s is a real number, while Omena observed that curve B is the set of points x comma y such that x equals negative 2t plus 2 and y equals 4t plus 1, where t is a real number. Since and computed the curve A will have no common points to curve B, contrary to Omena's computation that there will be one common point. Find the number of common points. So the first requirement is the, compute the number of common point or points, or probably no common points. So, and then the second requirement is who has the correct computation? Is it Sensen or Omeno? So at curve A, actually we can eliminate the variable s. So that's x is s plus 1. So in terms of x, so s would be equal to x plus 1. And also, y would be negative 2s plus 3, right, as given. So in terms of y, so s would be 3 minus y all over 2. So we have equation 1 and 2. And by equating these two equations, so x plus 1 and 3y minus 2, we will resolve 2x plus y equals 5. So that's curve A. And then let's solve for curve B. So at curve B, we can eliminate the variable t this time. So t in terms of x. So t would be equal to 2 minus x over 2. That's equation 3. And then for y, so y is equal to 40 plus 1. So t would be equal to y minus 1 all over 4. That's equation 4. So equating both equation 3 and 4, we will get again 2x plus y equals 5. So for Kirby, that's the solution. So, uh, okay, so since both curve and A are straight lines and coinciding with each other, the number of common points would be infinite. So that's the answer for letter A. And therefore, both Sensen and Umene's computations were not correct. So Sensen said there would be none, and Omena said there would be one, right? So, but it's infinite. So, okay, so let's move to question D2. So Newton said that it is possible to express Q and S each in terms of P and R using the polynomial equation below. When it has two double roots U and V, where U may or may not equal V, sorry. Prove Newton's claim is possible. So this is the polynomial equation. X to the fourth plus px cubed plus qx squared plus rx plus s. So, and the requirement is what is the expression for s in terms of p and r, right? So that's, and the second requirement is expression of q in terms of p and r as well. So, okay, let's solve this. So, since each of the factors x minus u and x minus b appears twice in the factorization of the polynomial. So it says there are two double roots, right? So 2 times 2 would be 4. So 2 each of x of minus u and x minus b. So let's equate that to our polynomial equation. So x minus u times x minus u, x minus b times x minus b, and we name it equation 1, okay? And then, so we can expand the right-hand side of the equation. So if you expand the right hand side, so if you expand this, we're gonna get this expression here. So x to the fourth minus 2vx cubed plus v squared plus x squared minus 2ux cubed plus 2uvx squared plus 2uvx squared minus 2uv squared x plus u squared x squared minus 2u squared vx plus u squared v squared. Okay. And then if we arrange the terms of the polynomial, so we will, so what did I do here? So I initially get x to the fourth, and then the 2ux cube, 2ux cube, so which is this, so here, and then minus 2vx cube, so which is this, I put it on the third term, and then plus 2uvx squared, which is this, right? Minus 2u squared vx, 2u squared vx, which is this, minus 2u v squared x, which is this, plus x squared u squared, x squared u squared, where's that? Yeah, so I just interchanged the variable here, and then plus 2u vx squared, so here, and then v squared x squared here, and the last would be u squared v squared. So if you would see, you can actually combine, here it's x4 to x cube u and v. So on this part here, let me clear this first. So I factor out 2x cube uv, and here it's plus, so it remains the same here. While on this part, I was able to factor out 2x from these two terms here. So negative 2x, so remain is uv and uv at the end. And then x squared. So on this part, I factored out x squared from the three terms. So if you look at the inside of the parenthesis, that is actually a quadratic, perfect quadratic. So u plus b squared result into that and then copy u squared v squared. So if you observe, this is actually quadratic in three terms. So x squared here and uv squared here and x to the fourth. And then the middle term here would be x plus uv. Okay, here. So if you try to expand this, you will get uh, the step here above, right? Okay, so now let u plus b equals negative b and uv equals to c. So we're eliminating the variable u and b. So I tried to use this equation. So, and to make it positive, I use negative b. So I got bx and then uv as c, right? And then so we have from equation 1, we have here, right? So, and that becomes x squared plus bx plus c quantity squared. So again, if we expand the right-hand side of the equation, we will be able to get this x to the fourth plus 2bx cubed plus 2bcx plus 2cx squared plus b squared x squared c squared, right? Okay, again, let's rearrange this. So if we rearrange this, we will be able to combine 2c plus b squared x, which has the x squared component. So we left x to the fourth and 2bx cubed, which is this, and 2bcx, which is this, and c squared at the end. So this is the part that we factored out x squared, right? So now look at the equation. If we try to equate the coefficients of the same degrees or powers on this equation, so we will see that p, so this p here is actually equal to 2b, right? And q would be equal to 2c plus b squared here. And r would be equal to 2bc, and s would be equal to c squared. So we will be able to get equation 2, equation 3, 4, and 5. So equation 2 is derived from p equals to 2b, and b is equal to p over 2. Of course, q is the same as mentioned. R would be the same, which is 2bc, and s is c squared. So let's move to the next step. So if we substitute equation 2 in equation 4, so equation 2 is b equals to p over 2 to equation 4, which is 2bc. So we eliminate the variable b, right? In this case here, so we will be able to solve c is equal to r over p. That's equation 6. And now for substituting equation 2 and equation 6, so equation 6 and equation 2 to equation 3, which is this. So q is 2 over r over p over 2 squared. So we will get 2r plus p squared over 4. So this would be q in terms of r and p. So that's one of the answer. So that's 2 points. And let's solve for s. So s would be from equation 5, that is c squared, and we know that c is r over p here. So that's basically s is r squared over p squared. Okay, so we already solved the expression of s and q here. So if you get this both, you get 4 points for this question. Okay, so let's move to question D3. So that's the third problem from difficult. And this is the question. So Gerald designed a new model of a rocket that it could reach a height given by this function. H of t equals 50 tangent of second of pi over 15t minus 5.3 ln of cosine t squared plus 1 on the interval of time from 0 to 10. here. Okay, where T is in seconds and H is in meters, Bea Gerald's co-designer on this new racket tested it at 3 seconds. So Bea tested at 3 seconds and concluded that it speeds up at that time. And then another co-designer, Julia, also tested the racket, but this time at t equals 5 seconds and concluded that it slows down at that time. So the question is, do the conclusions of Bea and Julia correct? So that's what we will try to find out. So let's do first Bea's testing here and that's also the first requirement. So Bea's testing at 3 is equal to 3 seconds. So we have h of t. So to be able to solve for the velocity, just take the derivative of h of t, right? So the derivative of h of t is actually equal to v of t, and this is the answer. So that long trigonometric function there. And then to be able to see what the value of your velocity at time equals 3 seconds. So substitute t is equal to 3 seconds, right, in the velocity. So which is this. And you will get the value v3 is equal to 72.7584 meters per second. Okay. So now let's solve a of three zeros. So the acceleration this time during Bayes testing at 3 seconds. So now to be able to get the acceleration, we need to get the derivative of b of t, right? So so to make it simpler, I use this method. So to differentiate the first term of the equation, use the product rule u prime v plus b u v prime, right? So let u equal to secant squared of secant phi or 15t and v equal to secant of pi over 15t tangent pi t over 15. So basically I split this first expression here, right here, and this one here. So this would be your v and this is u, right? So when I substitute that, so u prime, so if we take, so we're following this product rule here. So let's take u prime. So you'll get this um, result for taking the derivative of u. And of course, simplifying it would be on the second level here. Now this time, let's take the derivative of b, which is this. So that's b prime. So we'll get this value here. And let's when you simplify it, this will be the final answer for b prime. So combining them, so to get the derivative of the second term, we need the product rule. F times g prime is f prime g plus f g prime, right? So which is initially what I mentioned earlier. So let's move to the second step. So it's basically v prime of t. So the velocity of t would be equal to acceleration of t. So the derivative of b of t or b prime of t would be equal to the acceleration of t, and you would get this expression for a of t, sorry, this line here. And since Bea is testing it at 3 seconds, so just simply plug in 3 and you will get a3, or the acceleration at time 3 seconds is 370.9292 meters per second squared, right? So since this is acceleration, so the unit for s would be squared, right? So now let's go to Julia's testing. So we're done with Bea's. And of course, this time she used t is equal to 5 seconds, right? So same similar process. So h of t would be velocity would be h prime of t, right? And After we get the derivative of h of t, simply substitute t equals 5 seconds. So here, and we get v of 5, or velocity at 5 seconds, is 202.3951 meters per second. So now to get um, the acceleration, so take the derivative of the velocity. So we would get this. And let's substitute the value of 5 in the equation to be able to get a of 5, which is 670.7031 meters per second squared. Okay, so now let's try to answer if they got the conclusion correct for Bea and Julia. So let's use this table. So if our variable is velocity and acceleration, so to be able to speed up, so the velocity should be positive and acceleration should be positive as well. Or another way is it to be able to speed up, the velocity would be negative and acceleration would be negative. So that's one point here. And then if the it would slow down, so one would be positive. So let's say velocity would be positive and acceleration would be negative value. Or the other way around, negative velocity and positive acceleration. So since velocity v3 or Bayes testing has positive sign for acceleration, and a3 is positive also, therefore the rocket speeds up at 3 equals second. It means Bayes' conclusion is correct. So that's our conclusion for Bayes testing. So she got it correctly. And then for Julia's testing, since velocity v5 has positive sign and acceleration a5 is also positive, so therefore the rocket speeds up, right? It's still speeding up at t equals 5 seconds, so meaning she has the incorrect conclusion that it slows down. All right. So that's for D3. So let's move to question D4. So D4, at the American Historical Museum. So this is the problem. A gold plate has a Hebrew inscription as in the figure below. So we have this Hebrew inscription, and there's a given translation here. The translation of this Hebrew inscription are the following. So if you see the first one, right here, that is actually 1 equals 1, right? So, and then the second line here, so this is still 1 and minus, is it minus 4? So this would be minus 4, right? Yeah, so actually this is the answer here below. So find the general law suggested by this numbers written in Hebrew, express it in mathematical notation, and prove it. So if you try to get the translation of the Hebrew inscription, this would be the answer here. So 1 equals 1. 1 minus 4 is equal to negative quantity of 1 plus 2. And then the third line would be 1 minus 4 plus 9 equals 1 plus 2 plus 3. And then the fourth line would be 1 minus 4 plus 9 minus 16 is equal to negative quantity of 1 plus 2 plus 3 plus 4. And the general law for this number is 1, negative 4 plus 9. So there's an alternating sign for the left-hand side of the equation. So that would answer by this expression here, negative 1 n raised to the n minus 1. So it means if it's even, then we would have a negative sign for that element. And if it's odd, we would have a positive sign. And then if you look at the numbers, it's basically 1 squared, 2 squared, 3 squared, 4 squared, right? So this would be n squared here. At the to answer that series of numbers on the left hand side. While on the right hand side, again, if you see the first line is positive, second line negative, so it would be similar. So when we are having a negative, I mean an even an even number of rows or series, we should get a negative number. So that would answered by this expression. And then if you try to get the value or 1 plus 2 plus 3 plus 4, getting the sum of that series, that would be equal to n, quantity n plus 1 over 2 here. Okay, and so uh, let's prove it. So let's use step from n to n plus 1. So if I change n to n plus 1, so I'll get this variable expression here. And and of course on the right hand side, so this would be your value for n and n plus 1. So I added 1, right? And basically if I added 1 on the left, that is equal to the original equation here, right? And I just move it on the right hand side here, because n, right, initially it was n, so n plus 1 would be n plus 1. So this would be that value here on the right side. So uh, expanding the equation, so n squared plus 2n plus 1. And also here on the right hand side, we expand the equation and then factoring out negative 1 n, and then combining everything inside the bracket, which is this. So that will be equal to 2n squared plus or 4n plus 2 divided by 2. If you divide the numerator by 2, you would get n squared plus 2n plus 1, which is equivalent to the left-hand side of the equation. So we already proven that they are equal. All right, so let's move to the next. Okay, this would be the last question. So D5. So the problem is if w to the third power, or w is third power minus xw minus y is equal to 0, prove that the second derivative of w with respect to x, the second partial derivative of w with respect to partial derivative of x, partial derivative of y, is equal to negative 3w squared plus x all over 3w squared minus x quantity to 3, right? Third power. So taking the partial derivative of the given function with respect to x, and in this case, y would be our constant, right? So if we're taking the partial derivative with respect to x, so y would be constant, and w is the independent variable, and x and y are the independent variables, right? So this is the original equation. So let's take the partial derivative. So that would be 3w squared in with respect to x, right? So w, partial of w over partial of x. And then on the second term, so it's the product rule. So let's take x first and then get the derivative of w. So that's partial of w with respect to x. And then let's get the derivative of x, which is constant. So that would be 0. So we don't have that term. With respect to x, so partial of x with respect to x, and then times w. So we get negative w here. And then the partial derivative of a constant would be 0. So y is constant here. So we get this 0. And that is equal to 0. So if we solve partial of x over partial of w over partial of x, so we will get partial of w over partial of x would be w over 3w squared minus x. Okay, so now let's differentiate the function with respect to y. So this time x would be constant, right? Okay, so this would be the original equation again. So w cubed minus xw minus y equals 0. So again, 3w squared, but this time partial of y over partial of w over partial of y. So again, product rule for xw. So x partial of w over partial of y. This time x is constant. So when we get the partial derivative of x with respect to y, that would be 0, which is here. And then the negative y would be negative 1, because partial of y over partial of y is 1. And then it's equal to 0. Okay, so then let's solve for partial of w with respect to partial of y. And we will get 1 over 3w squared minus x. Okay, so since the second partial derivative with respect to x and then to y is equal to partial of the partial derivative of y with respect to x is also equal to partial of the partial derivative of x with respect to y, right? So that's the second partial derivative. If you are familiar with Clairaut's theorem, right? The last two expressions are equal. And then substituting the value of partial of w with respect to y in the above equation. So since we have this value, let's substitute inside. So I used this term here. So, and substitute partial of w with respect to y. So that's, I plug it in here. So if we take the partial derivative of a fraction, so we will have a quotient rule, right? So what's the quotient rule? Quotient rule of f of g prime is what? F prime of g minus f g prime g squared, right? So this is exactly what I did here. And then simplifying and substituting the value of partial of w with respect to x. So that, oops, let me clear this. So that would give you 3w squared minus x all over 3w squared minus x quantity squared. So therefore, the function is proven. So this is our answer, right? So I simply took negative from the equation. Let's see here. All right, yes. So negative, negative. So I forgot the negative here. Sorry. So I factored out negative. So correctly, let's put parentheses here. And that would give you the same thing we're looking for or we want to prove to. So which is this here. So negative means it's the entire fraction, right? Not just for 3w squared. Okay, so we've finished D5. If you got this, you would get 4 points for D5. And of course, if you have any questions, kindly write that down in the comment section of our Facebook page, Instagram account, and Twitter account. So there you go. So again, congratulations to our semi-finalists. That's Kyle, Beton Bedoro, Justine Magdalo, Feby Plormata, Brian Ivan Layug, Daniel Atanasio, James Carl Julian, and John Paul Pereira. So, okay, and thank you for watching us tonight or today in the other parts of the world, wherever you're watching this. And see you again next Thursday. And God bless everyone and stay safe.